We are exploring a body-centric approach for interaction with large wall computer displays. Our system develops a virtual model of the users in the room using either magnetic or optical tracking technologies. A complete model of the whole user's body allows for very rich interaction. A virtual shadow for each user is shown on the display. The shadow serves as a personal embodiment of the user in the virtual world. The user shadow supports interaction with both data and on-screen widgets, such as this keyboard. We are also exploring different shadow visualizations, such as blurred shadows, realistic models, and outlines. The virtual shadow is generated by a virtual light source somewhere in the room. The light can move in different ways. For example, it can follow the user as he turns. This allows the user to reach to the very far corners of the display without having to move. The user can also manually position the light with one hand while he interacts with the other hand. This allows him to focus interaction in one area on the display. In the real world, we store tools in our pockets. Our system works the same, except with virtual tools. To select a tool, the user reaches to the appropriate body location and presses a button. Body-based tools builds on real-world knowledge and reduces the need for menus and toolbars. The user can also access all his personal data, which is stored in his virtual stomach container. He can grab files out of his stomach and put them in the workspace. The system also supports collaboration in a number of ways. For example, as users get close to one another, their shadows collapse to an orthographic projection. This makes collaboration easier. When one user leaves, the shadows return to their normal behavior. Users can also share personal information. To do so, a user grabs a file from his personal storage area and literally hands it to the other user's hand. Once that user grabs it, they also have a copy of it. We're continuing our work on body-centric interaction approaches. We believe that combining real-world metaphors, such as body storage, with new interaction approaches holds great promise.